In this set language session 3, we are going to see operations on sets. First of all, we are going to see about what is union, and it is represented by U. For example, if we have two sets, capital A and capital B, it is represented as A union B. The same way, the another one operation is intersection, that is represented just like N. For example, if there are two sets A and B, the intersection is defined as A intersection B. Like this it is represented. And we are going to see one more basic operation, that is difference. It is represented like this. And for example, if there are two sets, it is represented as A difference B. So we are going to see these three basic operations. These are the basic three operations in the set language. Right. Now let's first go to union. What do you mean by union? A union B is defined as, for example, there is a set A and there is one more set B, and A union B is defined as X such that X belongs to capital A or X belongs to capital B. Let us see this using an example. Let us consider a set capital A is equal to 1, 2, 3. So if we represent it as a Venn diagram, it will be like this. And let us consider another one set, that is capital B, that is 3, 4, 5. And if we represent this as a Venn diagram, it will be like this. Right. Now, A union B, what do you mean by A union B? That is uniting A and B or joining A and B. What are the elements that will present in A union B? For example, if we consider this A and B, in the A union B set, the elements which present in A as well as which present in B will present in A union B, but it should not be repeated. For example, 3 is in A as well as it is in B. So you should not repeat this 3 together. That is, from this A and also from this B, you should not take 3. You have to take only 1, 3 from the two sets. So A union B is nothing but the element which belongs to capital A or the elements which belongs to capital B will be placed in the set A union B. Right. So according to this, our A union B will be equal to, so from A we are writing 1, 2, 3, and this 3 is here also, so you should not repeat it again. So 4 and 5. This is our A union B. Right. Now how to represent this in a Venn diagram? How to represent this A and B in a Venn diagram? How to represent it? Right. Consider the two sets capital A and capital B. Here if you see, this 3 is common for the two sets. So while drawing the set diagram, that is Venn diagram, we have to overlap one another. So this is our A set, this is our B set. Here we have overlapped one another because something is common here. So to mark the elements inside this set, first you mark which is common to both. Here the common element is 3. So we have to mark this 3 in the common area to the set A as well as to the set B. First we have to mark that. So 3 is marked here. After marking this, now let us try to fill this set A. If you go to the set A, it has 1, 2, 3. Already 3 is marked here. So the remaining 1 and 2 should be marked here. You should not mark it here. If you mark 1 and 2 here, then it will be taken as common to A as well as B. But 1 and 2 are not common. Only 3 is common. So 3 is placed in the common place, and the remaining 1 and 2 should be placed in the place which is not common. So uh, after filling the common, we have filled A set totally. So this is our A set. Now you can see 1, 2, 3 here as well as 1, 2, 3 here. Right. Now let us try to fill B set. The same way, if you go and see the Venn diagram, this is our B, right? Already 3 is filled. This is a common element for A and B, so it is filled here. So let us go and see what are the rest elements. The things which is rest is 4 and 5, and we should write this 4 and 5 only in the place which is not common for A and B. So if we place it, our 4 and 5 will be like this. So this is what the Venn diagram, and we have represented A set and B set in this Venn diagram. Now we are going to find what is A union B. A union B is nothing but 1, 2, 3, 4 and 5, as it is here. 1, 2, 3, 4 and 5. So we have to shade all these things. This is called A union B. So A union B is nothing but, that is, uniting A and B totally. So our A union will be like this. This is what our A union B diagram. So I hope so you would have understood what do you mean by A union B. A union B is nothing but uniting A set as well as B set, and in the A union B set, what are the elements will present? The elements which is going to present in A union B is nothing but it may be from A or it may be from B, and we should not repeat a particular element which is present in A as well as in B as common element. I hope so you would have understood what is A union B. Now let's try to see what is the operation intersection. What do you mean by this? Let us try to find A intersection B. Here A intersection B is defined like this. For example, we have two sets A and B, and if you want to find A intersection B, you have to find an element which is common for A and B. That is, if you try to write A intersection B, that element should present in A as well as it must present in B. If that particular element present in A and in B, then we can write it in the A intersection B set. Let us try to explain this using an example. Let us consider the same A set, that is 1, 2, 3, and the same B set, that is 3, 4, 5. Right. If you try to find A intersection B, A intersection B is nothing but the elements which are common for A and B. So our A intersection will be 3. This 3 is common in this A as well as in the B, because A intersection B is defined like this, that element should present in A and it must present in B. Here this 3 present in A as well as it present in B, so this 3 is our intersection. So our A intersection B is equal to 3. Now let us try to make it in the Venn diagram. A set is this. uh, you know how to mark it. So your intersection is nothing but this place which is common to A and common to B. So A intersection B area is nothing but the area which is common to set A as well as to set B. So here this is the area. So this is whatever A intersection B. Now let's try to see what is the difference operation. A difference B is defined like this. That is this. Let us consider two sets A and B, and A difference B is nothing but you can write the elements which present in A, but you should not write the elements which present in B. What do you mean by this? Let us see this through an example. Let us consider the same example. Set A is equal to 1, 2, 3 and set B is equal to 3, 4, 5. If we represent this in Venn diagram, it will be like this. Right. That's good. Now, what do you mean by A difference B? A difference B. It says you can write the elements whatever in A. So we can write the elements whatever in A, that is 1, 2, 3. We can write it. But the condition says in the same time it should not belongs to B. If you see here, this 3 belongs to B. It belongs to A as well as it belongs to B. But A difference B states us we can write all the elements which belongs to A, but it should not present in B. So this is what our A difference B. That is the elements which present only in A is considered. So A difference B, we can say in another way, A difference B is nothing but only A. Right. Now let us try to find A difference B. So our A difference B is nothing but 1 comma 2. As I told you, I outright the elements which present in A but not in B. So the element which present in A is 1, 2, 3, which should not belongs to B is 3. So we have to remove 3. So the answer is 1 comma 2. This is what A difference B. This is our A difference B area if you consider this. This is our only A part, right? So our A difference B is 1 comma 2. As I told you, A difference B can be said as only A, right? So you have understood what is union, what do you mean by intersection, what do you mean by difference. Now we are going to see one more thing, that is complement. After that we are going to see symmetric difference. Complement is nothing but it is from this difference, and symmetric difference is from this difference and from the union. Combining these two we'll get that symmetry. So let's go to see the complement. What do you mean by a complement set? Complement set is nothing but, for example, A dash is nothing but universal set difference A. So let us see this with an example. Let us consider an universal set, that is 1, 2, 3, 4, 5. Now let us consider a set capital A, that is 3, comma 5. Right. A dash is defined as, you can write the elements which belongs to universal set. Right. So we can write the answer is 1, comma 2, comma 3, comma 4, comma 5. But it compels us it should not belong to A. So we have to write the answer from the universal set, and we should not write the elements which belongs to the set A. So the remaining things are 1 comma 2 comma 4. These are the 3 elements which belongs to universal set, but it does not belong to A. So A dash is nothing but elements which does not present in A but present in universal set. So we can simply say A dash means the elements which present in universal set and does not present in A. So our A dash will be 1 comma 2 comma 4, because A dash is nothing but the things or the elements which does not present in A but present in universal set. So the elements which present in universal set is 1 comma 2 comma 3 comma 4 comma 5. Comparing this with A, what are all not existing in A, that we have to write that. The elements which does not belong to A, and comparing with universal set, they are 1, then 2 and 4. So this is our A dash. So A dash is nothing but element which does not belong to A but belong to universal set. So if we see here, this is our A set, which is a subset inside the universal set. Here 1, 2, 3, 4, 5 is our universal set, and our A set is 3, comma 5. So our A dash will be this place, that is 1, 2, 4. So if we mark it, it will be like this, right? So this is our A set. The whole thing is our universal set, and 1 2 4 is our A dash or complement set. Now let us try to uh, learn what do you mean by symmetric difference. Symmetric difference is defined as A delta B is equal to A difference B union B difference A. Right. Now let us see an example. A set A is equal to 1 2 3, set B is equal to 3 4 5. So if you try to find A difference B, just do like this. Take and write A set because A is in the front. So take and write A set, then difference, then write this B set. Now the easy way is to find which is common to these two sets. 3 is common to these two sets. That value that you have to mark it in the set which is in the front. So mark the common, that is 3. Now write the remaining, that is your A difference B. So our A difference B is now 1 comma 2. According to the definition, you know what do you mean by A difference B. A difference B is nothing but the set which the elements which are in present, which present in the A set, in the same time it should not present in the B set, that is only A set elements. So if you compare this, we have to write only 1 comma 2 comma 3 as answer, but we should not write this 3 because 3 presents in B also. We have to write only the things which present in A alone. So the answer is 1 comma 2. As I told you, the easy way is just if you want to find A difference B, take and write A set in the beginning, then put difference symbol, then B in the back. Now mark which is common to these two sets in the set which is in the front. Then after marking this, just take and write which are all not marked from the front set. Don't see the back set, just see only this front set. So the front set's remaining elements or unmarked elements are 1 comma 2. So this is our A difference B. The same way, now let us try to find B difference A. Right, now let us try to find B difference A. So B, so take and write B set, that is 3 comma 4 comma 5 difference. Then we have to write A set. As I told you, just find what is common for these two sets and mark it in the set which is in the front. That is 3 is common, so let us mark it. Now just take and write unmarked elements which are in the front set, that is 4 comma 5. So this is our B difference A. Now we know what is A difference B as well as B difference A. Now according to the formula, A delta B is defined as A difference B union B difference A. So let us write that formula again. Now let us unite these two. That is your A difference B is 1 2 and your B difference A is 4 comma 5. Just we have to join these two. So our answer will be 1 2 4 5. So this is our answer. If you mark it in the Venn diagram, this is what the Venn diagram of A and B. If you want to find A difference B, that is this part. That means we have to find only the elements which are in A but not in B. In other way, we can say A difference B is nothing but only A. This is this part. And after that, we have to find B difference A. B difference A is this part. That is, we have to find the elements which belong to B and it should not present in A. So this is B, and the element which does not belong to A is only this 5 and 4. So our A difference B is this part and our B difference A is this part. So combining these two, we are getting A delta B. So this is our A difference B part and this is our B difference A part. That is A difference B and this is B difference A, and we have to combine these two to get A delta B. So simply we can say, what do you mean by A delta B? As I told you, if you Try to find A difference B, the meaning is only A. If you try to find B difference A, the meaning is only B. So A delta B is nothing but the combination of only A and only B. So we are leaving only the elements which are common to A and B. This is what A delta B. So now we have learned what is union, what is intersection, what is difference, what is complement, and what is symmetric difference. Now let us see some simple concepts, simple examples or simple problems. What will be A difference A? So we are removing A from A, so we'll get nothing. So our result will be 5. And if from A, if we try to remove empty set, that is nothing, so A will be remaining there. Because from A set, we are trying to remove nothing. That means we are not going to remove anything. So our answer is that same A set. If you consider 5 minus A, the answer will be 5. Because from this set, here there is nothing. From nothing, we cannot remove anything. So the answer will be nothing. That is 5. Then A difference universal set. See here, this is our A set. This is our universal set. From this A set, if you try to remove this universal set, because universal set is the whole thing. So if you remove the whole thing from A, nothing will be with A. So A difference universal set is empty set. Universal set difference A. This is our universal set. The whole thing is universal set. If we remove this A, that is universal set difference A. If we remove this A, then we'll get this part. This is called by the name complement to A or A dash. I hope so you would have understood all these things. Keep these things in mind and try to practice some sums, and let us go into deep in the next classes. Thank you.